Hi Arlo. Okay, so I've had a chance to look at this and I see where you're coming to. So the problem now is to try to find, using first principles, the limit of the t to the h minus 1 over h. And so if you if you look in your textbook, when you guys did the derivatives and stuff, I think that you will find that if we put this in more general terms, if we have the limit as x approaches 0 of a to the x, which is sort of the general term for any exponential, minus 1 over x, which really mimics this t to the h minus 1 over h, right? Then you'll find that there is a definition in your textbook uh, telling you that that is equal to log base e of a, which we know as ln of a. And so this part here, taking the derivative of that, is going to give you the ln of t. And the rest of it we want in our equation, right? So if you've got your 1 over h piece of it and this piece of it, all represented by ln of t, and then you've got the rest of it, the t, sorry, I'm just having trouble reading this, t to the x minus 1 and e to the minus t left. Then I think you can carry on in terms of coming up with the form of the derivative that he's looking for. So I think that's all that's missing. So again, you can either Google this or look it up in your textbook, but that's a given sort of definition when it comes to the limit of a to the x minus 1 over x. It's impossible for you to work it out further, so that's something that is just learned in the first half of the course, that's equivalent to ln of a, so in our case that would be equivalent to ln of t, and so I think that will get you to where you need to go, okay? If not, email me back, because this is an interesting one. I never expected him to do this to us. So that's kind of an interesting approach that he's using in question 4. I think most people are going to find that pretty difficult.